LeetCode problem number 190, reverse bits. So this problem wants us to reverse bits of a given 32 bits unsigned integer. So basically, if n were to be 10011, the result of which would need to be 11001. Right, basically reversing this bit. Pretty straightforward. We can solve it in linear time. So first we have the result. It's currently 0. Right. So here we have a for loop starting from I, iterating through as long as I is less than 32. 32 because we're working with a 32 bits unsigned integer, so we have to iterate through 32 bits of n. For the sake of this example, I'll be iterating it through 5 times only, right? But do know that the back of it is padded with zeros until this length reaches 32. So the first thing we do is we bit shift result by 1 to the left. So obviously if we were to shift 0, it won't do anything, right? It's the same operator as if we were to, same operation as if we were to times 2, right? 0 times 2 is still 0. Afterwards, so here, let's break this down. So n ampersand 1, this is basically checking n and 1, right? So this is 1, and if we were to run the AND operation, this will give us, so basically this operation will check if both of these is 1, then only we will get the result of 1. Otherwise, we will get 0, right? It works the same as this, right? And in C++. So for this result, we will get 1, right? Afterwards, we use this and we check it against the result, right? So result right now is this. So we are going to run the OR operator. So OR works the same way as this OR in C++. So if either one of these bits is 1, we will get 1, right? Okay. Afterwards, we bit shift n to the right by 1. So n will become like this. So this one we removed, right? So we're shifting it by 1. The most right bit will be removed, and we repeat the same thing again. So result, bit shift 1 to the left, we push. So we have something like this now, the result. So we run n again, so n and 1, this will give us 1. Or the result, okay, result is like so, 10, right? So in the end result, we will get 1, 1. And then we push and back up. We bit y shift n to the right one more time. Okay, so now result is 11. Okay, so now result, push bit shift to the left by 1. We do the same thing, AND operation with 1. So in this case, since this is 0, and AND only works if both of these is true. So in this case, since this is false and this is true, so we will get 0 here, right? And if we want run the OR for the result of n ampersand 1 with 0, we will get 0, right? Because neither of these are 1, and OR will only work if either one of it is 1. Now since this is 0, so this will remain 0, nothing will change, and we'll shift again. And then result will shift. And then basically we have the same thing. With n ampersand 1, we get 0. So n will shift again. Result will shift to the left. Now we run it again, n ampersand 1. In this case, since both of these is 1, you will get 1 here. And if you were to run the OR, since this is 1, this will get 1 here. Right. And once we're done with that, obviously we will still loop through until I reaches 32, right? Because there are still more zeros here, right? There are more zeros at the back, but we're gonna skip past all of that and just return this result, which would be the correct answer, right? Just now n was, if you just a quick refresher, n was 10011, and we basically shifted n to the left, to the right, by adding more zeros and reducing the numbers at the back. Then after that, we add the result of n into our result by shifting result to the left. Okay, so yeah, pretty straightforward. That's all I have to show. Thanks.